All right, here's our last one, talking about the ideal gas law. All right, so now the ideal gas law, why is it ideal? Simply because it's under ideal conditions, all right? So if under certain conditions, all gases kind of behave the same. I mean, they're not perfect, but they pretty much do behave the same. So what makes the ideal gas law ideal? Well, it's under ideal conditions, okay? And when I say ideal, I mean it's not always realistic, okay? It's under certain conditions that we can predict. So what makes it ideal? It's under the same conditions for all gases. All right? And the formula for the ideal gas law is pressure times volume is equal to N times R times T. All right? So what do all these things mean? Well, P is pressure. Okay, we dealt with that before. Okay, pressure. And you want pressure to be in atmospheres, so you might have to convert a little bit. V is volume. So volume is the space it occupies, and volume we want it to be in liters. N is your number of moles. Okay? So moles is moles. So that means they might give you grams sometimes. So if you have to change your grams to moles, we know how to do that already, or at least we should. So if we have grams, remember, it's going to be your molar mass in grams to moles. So don't forget to do that calculation, how to figure out grams, how to figure out moles from grams. R is a constant, all right, meaning that it never changes. All right, and for us, we're going to use 0.00821, and the label is liters, atmospheres, over moles times your kelvins. All right, so R is a constant, always stays the same. So whenever you see the R, that's the number you got to put in. Temperature, T is temperature. Okay, and we want temperature always to be in Kelvin. And remember the formula for Kelvin. Kelvin is equal to 273.15 plus your degrees Celsius. All right, so there's the whole thing explained. Now you just got to plug in your variables and chug it out. All right, simple as that. So let's do one. So PV equals nRT. Here we go. We'll write the formula up here so you guys can see what's going on. All right, it says how many moles of CO2 could fit into 475 milliliters of a bag at negative 22 degrees Celsius and 855 milligrams of mercury. So notice how they're not in the units that we want them to be. So pressure needs to be in ATMs, volume needs to be in liters, and temperature needs to be in Kelvin. So we have to do some conversions. So first thing, change our milliliters to liters. Either divide by 1,000 or move it over 3. So 1, 2, 3. So that'd be 0.75. So that's going to be my volume. So 0.475. That's my volume. All right. Let's talk about pressure here. Pressure, here's right here. It's a pressure reading, millimeters of mercury, 855. So what we have to do is we have to divide by 760. So 855 divided by 760. And we should get 1.125. So that's my new pressure reading in ATM. Plug that in for pressure. Is equal to my number of moles, don't know it, times R, my constant. And my constant is right up here. It's already given to me. And then my temperature is negative 22, so 273 plus 0.15, sorry, minus 22. So 273.15. Let's see what we got here. Minus 22. And we should get 251.15. There, now plug it in and solve for n. So we want to get n by itself. So this numbers, bring it over because you're multiplying over here. Divide them into that side. Divide them into the other side, and you should be good. And then here's my next one. I'm just going to set this one up for you. I'm not going to figure out the answer. You guys can do that. So in order to have 1 mole of gas fit into a box that measures this at 1 atmosphere, what must the temperature be? So we're given moles, so we have 1 mole. We know our constant, 0.00821. We don't know our temperature. It's equal to 1 ATM. That's easy. And then our volume is length times width times height. And just so you guys know, a decimeter cubed is equal to 1 liter. All right, so 1.3 times 2.4 times 5.83 gives us a big number of, I don't think I did that right. Let's try that again. 1.3 times 2.4 times 5.83. That looks better. And you should get about 18.19-ish. Okay, so here's my volume, here's my pressure, here's my number of moles, here's my constant. I'm solving for temperature, but notice it wants to be in Celsius. This is going to be in kelvins. All right, so when you take these numbers, divide them in here, and then change your temperature into Celsius by not adding 273, subtracting 273. So once you figure out what temperature is, you subtract 273 from it, and that'll be your degrees in temperature. So hopefully this gives you a rough idea. We'll do more examples in class. But that is the ideal gas law. Under the same conditions for all gases, this stuff should all help and be useful. All right, so remember the specifics. We'll get over more details in class. So I hope this video helped. We'll talk to you guys later. Bye.